Hi, my name is Will Summers, and this is my presentation on the public lecture video that I attended a few weeks ago. So I went to Dr. John Phyllis's lecture on special relativity. He is a professor in the Department of Mathematics at the University of California in this video, and this presentation was presented on April 2nd, and there's just a picture of his book, Illustrated Special Relativity. So we'll start with the summary. Um, when he went over, he started with that our world is based on perspectives, which can be misleading. The first one he talked about is the idea that the Earth is flat. As we all know, the Earth is round, but from your single perspective, it's hard to tell that it's actually round because everything around you looks relatively flat, other than the hills and stuff. Um, Also, relativity can be explained with use of basic linear algebra and transformations, which he described, which I won't go into detail. Also, the laws of physics are still valid through all this, and one of the main points is the speed of light will never change throughout the theory of relativity. And finally, we know that wave speed is independent of all the sources around it. So that's a brief summary, and now I'm going to move on to an inertial reference frame that he also discussed. So first of all, an internal reference frame, it describes time and space homogeneously. And we have a picture here at the bottom right corner. You can see that it's identical at rest, and there are fixed observers. Also, the communication is all perpendicular and it's synchronized at 0. So you can see through our vector graph that the origin is at 0. It's synchronized through there. And moving on, I'm going to go ahead and talk about some of the theorems that were presented. The first one is the Bug-Rivet theorem. And looking at the picture on the right here, we can see a rivet with a little bug in there. But basically the theorem is based on perception, in that one perception is from the bug's point of view and the other is from the point of view of the rivet, and see whether or not the bug gets squished or not. And finally, I'll go ahead and watch. And here's another one, the Slinky transmission, which is a very interesting concept, which I'll show you a video for. As the video starts, you can see the Slinky goes down as being pulled down by the force of gravity. It is not moving from its bottom position until it is completely coiled up. This deals with the fact that the initial point, gravity is pulling down while tension is pulling up. And once you let go, the tension travels down the spring, but the gravity has yet to act on it because the force of gravity is equal to the force of tension in this problem. Now moving on from Slinky transmission, we'll take a look at the twin paradox, which I think was one of the most interesting things that he had to talk about, but also one of the most confusing things. So I'm going to go ahead and try and explain this as best as possible. So, two twins, the same age, started an origin. One twin goes on a moving path where he's constantly moving, so he goes out to another planet and then comes back. One other twin stays stationary. In the end, over time, two twins are at different ages. The stationary twin is relatively older than the traveling twin. Say the stationary twin is 100 years old and the traveling twin is 75. This is because as the twin travels, he experiences different planes of vision, and as he looks back, he at first is much older, but then as he goes home, his age starts to slow down, and making him much younger. Again, very confusing paradox. And finally, one of the things that I learned, I thought was the most interesting, was that everything we experience is based off our own perception. You can kind of explain this through this picture that I found. It's really confusing, but the guy on the left, he sees 4 blocks. However, the guy on the right only sees 3. And it's all about, based on where you are, based on where your specific origin is, you experience a different perception of what you see around you as compared to everybody else. I thought this was a very interesting principle. And finally, after watching this public lecture, it got me thinking a little bit more on the history of relativity. I consider myself a history nerd, so I thought some research into this would be pretty cool. So it all starts out with Galileo's principle, which is explained by that all observers are distinct from each other. Like in that picture I just showed you before, each observer has their own origin. This then broadens into Isaac Newton's theory of absolute time and space, which the independent absolutes of time and space are different aspects of time and motion. That further goes on to Maxwell's eighth theory, in which he says that all phenomena are within one medium. But however, Einstein finishes up with what our theory of special relativity today, which says there is no apparent time, with everything in all motion and all observers in all positions and all paradoxes. So that is my public lecture. I'd like to thank you for watching. I really did enjoy going to the lecture and hearing what everything he had to say about special relativity. Although it was a very confusing topic, I think it was pretty cool to hear about. Thank you.